So I want to talk a little bit using weighting for data waves and the AgeDepthFit function. So we're back to U1338. I have data that contains age and depth for nanos and for PMAG. And I've already actually formed the data, age data for fit and the depth data for fit somewhere down here using the multiple data selection function that you saw in a different video. These data that I've put together, we want to go to depth to age, and we want to use AgeDepthFit. And it's 1338. The data we want is in AgeDepthFit. And that's depth data for fit, age data for fit, the event. Let's start out with perhaps a fourth order fit, with the fit through 0, yeah, cursor's no, age is the x-axis. Okay, so here we are. We've fit a curve, and from that curve, basically taken the first derivative of that curve to get the sedimentation rate. X's are nanos, and these sort of starburst guys are PMAG. So here's a good idea of why we want to use weighting. PMAG data, especially at sea, is probably your most dependable. That's because it's done from the continuous core, and the only problems they have is making sure they're identifying the correct reversal. Nanos, on the other hand, are a little less reliable in the sense that they're generally done from the core catchers. So there is a certain ambiguity in the depth position of first and last occurrences. So with that in mind, we'll take a look at the data from 1338. And what you can see is there was quite an expanse, about from maybe 160 meters down to about 200 meters, where we actually didn't have any paleomag data. This was just pure carbonate. There was nothing magnetic in there. So we want to have the nano data to kind of give us an idea of what's going on in this gap. But we don't want it to be weighted the same as the PMAG data. Let's weight the PMAG 10 times what we're weighting the nanos. Oh, and I should say, when you run AgeDepthFit, everything is weighted as 1. Here's the table, actually. So other than the first line, which we've actually added into the data and forced through the position of 0 depth, 0 age, everything else is 1. So let's take the PMAG and make it 10. Let's go to CODD data, depth to age, and then set weights. Site 1338, PMAG data, and we want to enter a new weight, and you can see I was practicing this, so we're going to use 10. Okay, now we can see the PMAG data is red, and the nanos are still blue down here, weight of 1. Now let's run the same fit again with the different weights. Here we'll go up here, data depth to age, and now we want to use refit. We want to keep the weighting. We just want to rerun the fit now that we've changed the weights. And there it is, some agreement. Let's expand this. We can see that our fit is off by, maybe 50, 100,000 years. It's kind of systematically offset. Interestingly, this slope and this slope are the same, meaning this has the right sedimentation rate for that depth. It's just a little bit different, just a little slightly wrong in age. Now if we look at this middle part, what we'll see is there's definitely the PMAG data is showing a lower sedimentation rate than the curve fit. And I know from other work on sites nearby, 1338, and actually work that's been done on 1338 subsequent to the data collection, that there is a lower sedimentation rate at around 9 million years. So we want to actually see if we can capture that. And we're not going to capture it by thoroughly by weighting. What we need is more flexibility in the curve. So what we're going to do is up the order. And we'll go from 4, let's try 6. Okay, it changes things a little bit. You can see we actually got better down here. It's not too bad. It's pretty close. See how we did up top. Oops. Yeah, also quite good. But we still have this problem in the middle. You can see that we're not fitting that lower sedimentation rate. So let's continue to go on up, and actually, you may have noticed when I first did that AgeDepthFit, I know that 11 is going to work pretty well. Okay, so we're getting this error message that tells us that the AgeDepthFit is recurved, and we'll just take a look at that in just a second. So let's do the fit. Okay, so here's that recurvature. This is not uncommon when you use a higher order fit on deep holes, where you commonly will have a kind of like an orphan point or two following a gap, and sometimes large age gaps. So what I like to do is just to actually get rid of these. Later on when if you present this curve as representing the age versus depth relationship for this site, you can say below, whatever this final point is, you can just do something linear between here and there, or you can just say, don't worry about it. Let's put a cursor on one of these points and go up to CODD data, depth to age, and say weight 0. Now you see it's changed markers and actually color, although it's pretty subtle between weight 0 and weight 1. And weight 0. Okay, now we're not using those points in the fit, so let's just run the same fit again. And there you have it. Now you can see we've actually fit these guys in the middle pretty well, and that's given us this big dip in the sedimentation rate that we were expecting to see. So that's pretty much it. That's another thing about this age depth curve, just give you a little tip. If you want to know how to kind of navigate around it pretty nicely, you can put a point here. Okay, and that's going to give you your sedimentation rate if you're on the sedimentation rate curve, so that's 21 meters per million years. But we can also change that, and actually let's do both at the same time. All styles. Let's go here again. All styles. Let's do a hair. When you do a hair, you can read off the axes that you're interested in. So what we're seeing is a 21 meter per million year sedimentation rate at a depth of 210 meters. And if you're wondering about the age, just take the B cursor and put it right there, and then you're going to be able to read the age off the bottom scale, especially if we added some ticks.